Welcome to the E-Pathshala lecture series on computer science for postgraduate students. In this session, we are going to learn computer graphics and visualization. So, the basics of this subject will be introduced to you in this session. So, we are going to start with the basics in the module 1 and some more basics as part of module 2. And this session gives you a brief introduction to this subject, and further we will discuss more details in this subject. So, to start with, we have the basic terminology. We have to understand this as part of the course. Then we need to look into the graphic types. We have to also learn about the coordinate systems and other basics in this. So, the keywords that are meant for this are resolution, refresh rate, color depth, scan conversion, graphics standards, and many more. So, in fact, this subject gives you a brief introduction to this graphics and the visualization. We are going to start with the basic terminology, then the important definitions, and we will look into what a display processor is and what is its functionality. So, what is a raster and vector graphic, or what are the graphics types, and coordinate systems that are very much important to graphics, and the graphics standards. Here in this we have the basic terminology, and as you can see, terminology is listed here there, which are pixel dimensions, resolution, aspect ratio, refresh rate, scanning modes. You have dot pitch, color depth, viewing angle, scan conversion, and the other terminology includes graphics systems, graphics types, and graphics software standards and coordinate systems. So, we are going to understand what a graphic is, or why the subject is so important as part of computer science is concerned. So, without anything that we see on the monitor, anything that we see on the monitor on a display device is actually a graphic, isn't it? So, we cannot live without it, and every day starts with seeing something on a display device, either it is a mobile phone or it is any laptop or an iPad or whatever, we see actually a graphic. So, anything that we see on a display device is a picture or a graphic, as the definition goes. So, this subject of computer graphics and visualization actually is all about learning the storage, representation, display, and manipulation of pictorial information. So, we call it pictorial information because it is about pictures. So, storage is one important thing, representation is one another important thing, and display. So, how do we render pictorial information on screen is another important thing, and finally, how do you manipulate or process pictorial information also takes importance. So, the definition of graphic is actually anything that we see on a display device, even a dot, even just a dot on the monitor or a screen on the screen is actually a graphic. Okay. So, with the basic terminology as I introduced to you earlier, so we have so many definitions without which we cannot go further. So, the definitions include, say, the first definition which we have to understand is pixel dimensions. A pixel is a picture element, we call it picture element, in short form it is called as pixel. So, if you see, your monitor is actually a collection of pixels, your monitor is a rectangular array of pixels. Your monitor has got say for example, generally your monitors are set to pixels like say 640 480 resolution, set to 320 240 resolution, set to 1024 768 resolution, and so on and so forth. So, you might have seen on your display devices that these are some of the standard display settings. I think you would change it on your monitor, you would often require to change these things on your monitor depending on the requirements of the application. So, here the number of pixels along the width and the number of pixels along the height make the pixel dimensions. So, it is important that you understand that this number here on the left 640 480 say or 320 240, the 320 indicates the number of pixels along the width and 240 indicates the number of pixels along the height. So, always this is important that for a rectangular display, like generally the left number on the left side will be more and the number on the right side will be less. So, indicating that it is a rectangular display. So, we have some display standards, as you are aware of. VGA is one of the standards long back. It is video graphics array. So, it is basically a standard that talks about the number of pixels to be there on the horizontal side and the number of pixels on the vertical side. So, it is 640 into 480. So, SVGA is super video graphics array. So, it is another standard. So, it is 800 by 600. So, XGA extended graphics array 1024 by 768, and HDTV, nowadays we say we have HDTV at home. So, HD supporting video at our on our laptop, on our display device, on our all our display devices like television and everything comes now with HD support. So, we call that standard as HDTV, and it is 1920 by 1080. So, there are so many pixels in a HD TV on a HD standard. So, another standard for HD itself, there are two standards, one is 1920 1080, the other standard is 1280 by 720, and we call it progressive. So, we will learn more about what is actually progressive and other details later. So, here as we have learned pixel dimensions, now it is the number of pixels along the width and the number of pixels along the height. Now, you should try to understand the difference between resolution and pixel dimensions. Both are not the same, as we take it the same most often, but they are not the same. Resolution is the number of pixels per inch, is actually the term number of pixels per inch or dots per inch is resolution. So, when we say resolution, actually we mean to say that how many pixels are there in an inch space. As you can see here, a high resolution display has got many pixels packed within an inch space. So many pixels within an inch space, while a low resolution display device has got few pixels packed within an inch space. So, that means we can pack more information in a high resolution display, but we cannot pack more information within the same inch space in a low resolution display. So, that is where the difference is, and the standard resolutions, some resolutions are given here like 76 pixels per inch and 80 pixels per inch and so on. And generally your printers also have got resolutions like say DPI, which is measured in DPI, which is dots per inch. Your printer resolutions are far larger, far higher values than the monitor resolutions. For example, your printer resolutions are 2000 dots per inch, and even higher resolutions are available for printers. Whereas for display devices, your resolutions are generally like 76 ppi, 80 ppi and so on. So, that is 80 pixels per inch. So, that means now you should be able to compare resolution and pixel dimensions, which are so important. Generally we say that resolution is 76 pixels per inch and say pixel dimensions are 1024 by 768. That means that you have so many pixels packed in an inch space, like resolution 76 pixels in an inch space, and you have 1024 by 768. That means the quality of a picture is not determined by the number of pixels, but actually determined by the resolution. An important quality feature of a of an image is actually resolution. Okay. So, of a display device, the quality feature is actually resolution. So, the more information, the higher the resolution, the more the information you will be able to see on the display device. So, in fact, you can ask for a high resolution monitor or a display device when you go and buy, and then to ask for a high pixel dimension monitor. So, let us understand the next definition, which is aspect ratio. Aspect ratio is the ratio of width to height, and generally you might have noticed that the aspect ratios are standard aspect ratios are 4:3, 16:9, and these settings you have it on your television set, on your display device, you can change these settings. So, aspect ratio gives us the ratio of width to height of a display device. Then the next important definition that we have to understand at depth is the refresh rate or the frame rate. So, refresh rate is the number of frames or screens scanned in a second. So, every display device has got this parameter which is called the frame rate or the refresh rate. So, whenever your device or your display device has to throw something on screen, it actually displays the image or scans the screen image on the screen 60 times a second. So, it displays the same image 60 times a second. It redraws the image 70 times a second, 75 times a second, and so on and so forth. Your monitors have got these settings. You can change these settings, like your monitor can be changed to 60 Hz monitor or 65 Hz, 70 Hz, 75 Hz, because the refresh rate is measured in Hz. So, as you see here, the diagram here shows that when you the monitor is scanned like this is a horizontal line, this is called a scan line. So, the monitor starts scanning the picture from the top left corner, and then it proceeds towards the right, and this is a horizontal scan line, and as we it retraces, there is a dotted line that you could see there. There is a retrace, this is called a horizontal retrace, and then again the next line is scanned, again there is a horizontal retrace. During the retrace process, it does not draw anything. So, it just waits for the next scan line to be redrawn. So, it keeps doing this, and when it comes to the last scan line here, it does what is called a vertical retrace. This vertical retrace again is the electron gun, or what is called the pixels that are actually not drawn, nothing happens on the screen when there is a vertical retrace. Simply it is rearranging the position of the electron guns inside, so that the screen is again redrawn from the top left corner. This is how there is a horizontal scanning, and at the end of the frame it is vertical scanning. Again the position of the cursor starts from here. So, there is the screen is redrawn again from the top left corner. So, that is how we that is how a screen gets redrawn. This is called refresh rate. So, a screen gets redrawn 70 times or 60 times or 70 times or 75 times in a second is a standard refresh rate. For your monitor, you can do this, you can change this setting, because even at 60 Hz, if you have an olden day CRT monitor, for example, if you are using a CRT monitor of the olden days, now they are being replaced by all the flat devices or flat panel flat screen devices. So, if you have a CRT like device, you can better adjust your refresh rates to 75 Hz, 70 to 75 Hz, because even at 60 Hz, our eyes are able to detect the flicker of the screen. So, we tend to feel a lot of strain on the eyes even at 60 Hz. So, please you can change the setting to 70 or 75 Hz if you have an olden day CRT monitor like display device. Okay. So, next important thing, as far as these are important to understand here, that is refresh rate is actually the number of screens or frames scanned in 1 second measured in Hz. And here these scanning modes, if you look at, there are two ways in which a screen can be redrawn. A screen can be actually the image on the screen can be reproduced. So, which is interlaced scanning, and interlaced scanning is one where we have a screen, the same screen is actually drawn in two passes. That is, as you would notice here, it is a technique used to increase refresh rate. That is, we do this so as to increase the refresh rates, because as we know that our human eyes are so sensitive even to small changes and flicker on the screen. So, we want higher refresh rates. So, our aim is to increase the refresh rates. So, we go for this mode, which is called interlaced scanning. So, in interlaced scanning, in the first pass all the odd lines are scanned, and in the second pass all the even lines are scanned. So, in two passes the whole of the screen gets redrawn. So, that means it is actually an interlaced monitor. So, how do we know that is, if you happen to buy a HD display device, for example, a HD TV for your home, you maybe the when you go and buy, the specification says like this, say for example 1920 by 1080 is one standard, as we know. The 1920 indicates the number of pixels along the width, and 1080 indicates number of pixels along the height. And there is one important character down by the side of 1080, which is I, the I indicates interlaced. That means, if you go and ask for HD TV, they might show you like say we have 1920 1080 I display device. So, that means this I indicates interlaced, and that means the display device uses interlacing technique to actually refresh the screen as many times as per the refresh frequency. So, here the other kind of scanning mode for a display device is progressive scanning. So, in progressive scanning, the image is actually not scanned as unlike your standard interlaced scanning. Here the picture, the coarse details of the picture are displayed first and finer details are only displayed later. Here coarse details here means the important details that make up the image are displayed first and the finer details appear later. So, with passage of time, that is slowly the image before you gets clearer and clearer, that is what is called a progressive scan. So, here if you see in the example here, the HD 1920 1080p indicates that generally it is colored red to indicate that the standards, when you go and buy, you see in a shop like say 1080p, they say 1080p is our display device, 1080i is the television we have. So, 1080p indicates that P stands for progressive, and the scanning mode that it uses, the television uses is progressive scan. So, how these two are different? Now, which of these scanning modes is better? So, if you look at this, the progressive scan and the interlaced scan, if you could closely, if you identify, if you look at these things at close, these two images at close, you would see that the progressive scanned image is much more better and superior in quality to the interlaced scanned image or picture. So, that means, if you go to a television shop, you better look for a display device or a monitor or a television that offers you progressive scan, okay, but these are obviously a little costlier than the interlaced scan models. So, the progressive scan is much more superior in quality. So, the next terminology is that we are going to learn is dot pitch. The next definition, dot pitch is the distance between centers of two successive dots or pixels and measured in mm, so millimeters. So, if you see here, the dot pitch is the distance between the centers here. So, a color pixel is indicated or is positioned in the shape of a triangle, and here you have the red dot, the green dot and the blue dot. So, these three are positioned like a triangle in the shape of a triangle, and the centers between two successive dots is called the dot pitch. So, the smaller the dot pitch, the better the resolution, the lesser the dot pitch, the better the resolution. So, the higher the dot pitch, the poorer the resolution. So, that is a straightforward relationship between the two. Next definition is about color depth. Color depth is the number of pixels that the number of colors that a display device can reproduce. I think some of the olden day display devices could produce only say 256 colors. Later, with improvement in technology, they were able to produce like say 10,000 colors and 16 million colors, and later even beyond that. Now, if we say the number of colors that can be produced by a display device is called the color depth, and the number of bits that we assign per every pixel. So, it depends on how many number of bits we assign per pixel. So, we can assign 24 bits, we can assign 32 bits. So, it depends on how many vibrant colors, how many variety of colors that we want for our display device. So, 24 bits per pixel indicate that its 2 power 24 colors are possible on the display device. And if you see, if it is 24 bits per pixel, it is red 8 bits, blue 8 bits and green 8 bits. So, all the three are given 8 bits each. So, that total put together it is 24 bits per pixel. So, for 32 bits per pixel, you can still distribute the number of bits among the three colored dots here. So, that makes the color depth, and now we are able to see so many colors on the display device because of the higher color depths. So, the next definition is about viewing angle. So, viewing angle is now some of the LCDs or flat panel display devices, the LEDs and so on, all the flat devices if you see, they have a specification called as viewing angle. That is, if you see only straight perpendicular 90 degrees orthogonal, if you see the device only from 90 degrees or perpendicular direction, so you will be able to see that at the best possible viewing experience you will have. So, but if you try to see it from an inclined angle, so you will have a different color setting and all the things appear differently than what when you notice, when you observe, when you are exactly sitting straight. So, when you deviate yourself from the display device, automatically the colors, the everything appears differently. So, that is where the viewing experience is lost. So, for acceptable viewing, there is a limit to the viewing angle. So, that viewing angle is an important criteria. So, that comes with the spec of a display device. Another important point is the display processor. Actually, this is the hardware element of your machine. So, graphics card we call it, or we call it the display processor, you can call it. You might have heard of these names like NVIDIA graphics processor. These devices actually are made to enhance your graphics capabilities for the display device. And if you see that here the display device, that is the graphics processor, actually what it does is it takes all the picture information from the program or in the form of a program. Say for example, a picture is to be displayed and the picture's information is actually stored as part of a program or is in the form of a representation. This representation is given as input to the display processor. What the display processor does is it converts the pictorial information that is given there into equivalent pixel intensity values. So, this process of converting the information of a picture which is not in the form of pixels into some pixels or a rectangular array of pixels is called scan conversion, and that is what this display processor does. So, if you see the architecture of this processor, display processor, it is there is a system bus, there is a display processor, and it has got the display processor has got its memory, its dedicated memory, display processor memory, and there is a frame buffer. The frame buffer here stores the information that is to be actually thrown, or the pixel intensity values are actually stored here in the frame buffer. While some other image is to be shown, the display processor already calculates the amount of the intensity values required, and that is again stored in the frame buffer, which is then fed to the video controller, and then again finally it is fed to the monitor. So, the display processor does an important job called scan conversion. So, as you see this in the definition here, it is the process of converting or digitizing a picture definition given in an application program into a set of pixel intensity values. So, that is where your scan conversion process takes place, and that is done by the display processor. Let us understand the types of graphics systems based on how a picture is displayed. So, if you look into this, there are two ways in which a graphic system a picture can be displayed on a device, on a display device. One is the raster type and the other one is random type. In raster type, a frame is scanned completely starting from the top left corner and ending at the bottom right corner. So, in raster graphics system, what happens actually is the screen is drawn starting from the top left corner and the picture gets redrawn till the bottom right corner without bothering about whether there is some picture to be drawn in between or not. It just starts scanning right from the top left corner till the bottom right corner. Whereas, in the case of random type, only the part of the frame that contains the picture definition is scanned. So, you can now understand the difference here. In raster scanning, a picture is drawn straight from the top left corner of the monitor to the bottom right corner, even without bothering about whether there is the full screen has some picture or maybe a part of the screen has got some picture. So, it keeps scanning, while the random type of scanning is it just scans where the exact picture is to be plotted or is to be drawn. Next important thing which is to be understood is the graphic types. So, based on how a picture is represented. So, we most of us have experienced, so we do not generally find a difference between the graphic types, we just take it for granted. Actually, a picture can be either a raster graphic or a vector graphic. So, if you see something on your screen, a picture or an image on your screen, it is made up of either a raster graphic or maybe a vector graphic. So, a raster graphic, how it is different? Let us try to understand the difference here. If you see the difference between the two here, a raster is basically a rectangular array of pixels, so which is a matrix of pixels, that is how a raster is represented, and it is resolution dependent. So, let us look into the raster attributes of the raster graphic. So, it is resolution dependent. To understand what is this resolution dependency, we have to look at an image that is displayed. Okay. So, for example, if you stretch an image, what actually happens? If you stretch an image, if you shrink an image, what happens is, if it is a raster graphic, if you stretch an image, the quality is lost, the image gets pixelated, or maybe the image looks blurred, or and many more. So, the pixels actually get expanded, and now it leads to loss of information. So, what we mean to say by that is, raster graphic is resolution dependent. That means, if an image is created for say 640 480 pixels that make up an image, and if you see it in a 640 480 resolution display device, so then what happens is, the image exactly appears as it was done, but if you stretch the image beyond that, it gets distorted, or we call it pixelation. So, that is why it is resolution dependent. So, then the next attribute is, the next property is file size. So, file size is huge for raster graphic because it is resolution dependent. If you create high quality images, obviously the file size is larger, and they are easy to edit and manipulate. As you know, there are many software, so much of software is there to so many software tools are available, proprietary software, open source software are available to edit a raster graphic. For example, to name one proprietary software, you have the most popular, the Adobe Photoshop, one of the popular image editing tools, which is meant for raster graphic editing. And to name one vector graphic editing, we will come to that later, but so to it is easy to edit, and the open source equivalent of Photoshop, you can take one of the open source software as the GIMP. The GIMP is an open source image editing software meant for editing raster graphic. And here we have the example raster graphic types, which are the BMP and JPG are some of the formats, and one of the popular standards of a raster graphic is Opengl. Opengl is one of the open graphics library. It is one of the popular standards for raster graphic. There are many other standards which are not mentioned here. Let us come to the vector graphic type and how it is different from raster graphic. Any picture is represented as a set of mathematical equations. So, a picture definition is stored inside as a set of mathematical equations. So, how a picture is stored is, for example, a picture is basically made up of many points. So, you can also imagine a picture to be made up of many mathematical equations like squares, like circles, like rectangles, like many other standard shapes. So, a combination of all these, for each of these we have mathematical equations. So, when you combine them to form shapes, so we have various pictures. So, you can break up a picture as a combination of various mathematical objects. So, any picture is represented as a set of mathematical equations. So, one of the important difference that you would notice between raster graphic and vector graphic is, it is resolution independent. That means, even if you scale it up as much as you want, even if you enlarge the image, even if you stretch the image as much as you can, but still the quality of the image, the display quality does not get disturbed, does not get deteriorated, but it but the quality is again and again it's much more better and superior. With change in size there is no change in quality. So, that is where it is resolution independent. So, and another important difference that you can notice is it is the file size is much more smaller, but due to this difference, due to this very feature of vector graphic, raster graphic is actually much more popular because of this very reason. Vector graphics are difficult to edit and manipulate. So, for example, you can take a vector graphic editor software like CorelDRAW, and you can also, you might have heard about Flash. Flash is one of the most popular vector graphic software tools. So, you have one of the important standards that define that gives the vector graphic, that supports vector graphic, is the SVG, stands for scalable vector graphics. This is where we have to understand how a picture is made up of and how the raster and vector graphic are different. So, let us look at these graphics software standards. A software standard is actually a set of algorithms defined for drawing graphics. So, whenever we say a standard, actually it does mean that how a picture is to be redrawn, how a picture definition is to be represented, how a picture is to be drawn, or what are the various what is called standards. So, a set of software standards is basically a set of algorithms, a set of some pseudocode is always available, and what you can do is as if you take a standard and you can integrate that with one of the programming languages or popular languages. So, there are many standards available. For example, GKS is graphics kernel system. So, you have FIGS, programmers hierarchical interactive graphics standard. You have CGI, computer graphics interactive. You have VRML, virtual reality markup language. You have Opengl, open graphics library. You have SVG, the scalable vector graphics. You have DirectX by Microsoft. So, these are many of the graphics standards. So, what do you mean to say by graphics standard is they contain representations of images, how an image is to be drawn, how a line is to be drawn, how a circle is to be drawn, how the basic shapes are to be drawn, how to create the attributes, how to actually combine them to form various pictorial elements. So, is all defined in the standard, and our job is to actually use a programming language to actually implement the algorithms in the standard. So, the algorithms have been implemented, and you can now find a lot of libraries which you can use straight away in your programming language, and you can call these functions and within the programming language, and now you can run and execute. So, the beauty of these standards is that they have a language binding. So, what is a language binding? Language binding is that suppose if you are good at Java, or suppose if you are good at C, or suppose if you are good at C++, what is that you can do is you can download the required libraries corresponding to the standard, and you can actually integrate that with your programming language of your interest. For example, take Opengl. Opengl has got language binding with C, Opengl has got language binding with C++, Opengl has got language binding with Java, and so on. So, if you are good at C, what is that you can do is download the Opengl libraries, the DLLs, the header files for Opengl with C, and then integrate that is in the environment, you integrate them, you add it in the header, you add these libraries in the header, and then while you write your C program, you can embed the Opengl statements in between. So, that is called the language binding, and every standard here, most of the standards here have got a language binding with the standard. So, graphics programming, you can use Opengl, one of the graphics programming environments. You can use DirectX, these are meant for 3D, the Opengl, DirectX are meant for 3D. So, CG, graphics for C, the VRML, popular markup language for graphics on the web, for 3D graphics particularly, virtual reality markup language, the FRAN, functional reactive animation, processing, processing is one of the recently emerging languages, and allies Java. So, Java is well known open source platform for 2D as well as for 3D. So, Java 2D and Java 3D, there are many methods and libraries available as part of the Java 2D and 3D packages. So, you can call these libraries while within the Java program. So, at the last we can come to the coordinate systems, which forms the most important part of graphics study. So, that is every standard or every program that you write in graphics actually deals with a lot of coordinate system transformations. So, if you take for example 3D graphics, it starts first with modeling the objects. So, what is that first you do in 3D graphics? If for example, if you have tools like 3D Studio Max, if you take tools like Maya, what is that first you do is first you open the interface of 3D Studio Max or Maya, then you have various views of the 3D objects, that is you drag and drop some standard objects that are available on the interface, you will be throwing them on the screen, and then you will be actually repositioning them wherever you want, and then later you would give them kind of shades, you would give them lot of textures, you would give them lot of what is called some reflection and other properties. You would later find a suitable viewing position and then capture that as part of your 3D animation or a 3D image or whatever you wish. So, the final step is what is rendering. So, in a typical graphics program, what actually happens is a lot of conversion of coordinates from one coordinate system to the other. So, we need to understand what a coordinate system is first. First, we need to have a feel for what a coordinate system is. As we know, as we have learned that a coordinate system is nothing but two perpendicular straight lines, and we call it Cartesian coordinate system. And basically to have a better understanding, a coordinate system is actually a reference position in space. What is a reference position? A reference position is something but a position that you have chosen in the space, and with respect to which you measure the world, or with respect to which you locate a position, other position in the world. So, it is basically a reference point, or to be more precise, it is basically a reference frame in space. So, a coordinate system fundamentally is a reference position, a reference frame that is in space. So, if you see here, we start with the modeling coordinates. So, that is, imagine an object is first dropped and dragged and dropped on screen. Imagine there is a 3D object. What is the first step that we do is drag and drop an inbuilt object, place it on the screen, and the next step is to extend it, or maybe you can stretch it, or you can maybe scale it, or you can orient it, rotate it, or whatever you do. Okay. When you are doing all that, what you are actually doing is you are doing all that with reference to one of the coordinate systems, which is called the local coordinate system, or also called the modeling coordinate system. Okay. What is a local coordinate system or a modeling coordinate system? It is actually the coordinate system that has got its origin, which is at the center of the object, and with respect to which we are actually deriving three mutually perpendicular directions with respect to the center, and that forms the coordinate system for that object. And when we stretch or increase its size or maybe reorient it, everything is done with respect to that coordinate system, and we call it as actually the modeling coordinate system or the local coordinate system. That means, if you have a different object, like say here cylinder is one of the objects, it has got its own local coordinate system, and square or cube is another 3D object which has got its own local coordinate system. And also when we say it is local coordinate system, every object has got its own separate coordinate system. And when we place all these objects in the 3-dimensional world, that is, imagine a reference position as shown here, which we call it as world coordinate system, and when we place all such objects in this coordinate system, we call it actually the world coordinate system. Now, all these objects assume world coordinates. Initially, they were all the objects were assuming local coordinates, which are also called modeling coordinates, and when we have put them in with respect to another reference position, which we call it as world coordinate system, now all these objects assume world coordinates. And the next step is to convert the world coordinates to viewing coordinates. What is actually viewing coordinates is, again, imagine that you are going on a nice picnic. You have gone to a nice place or a hill station. You are on a hilltop from where you wanted to actually take a snap of the world. So, what is that you do first is you position yourself, isn't it? You stand at a nice vantage point, and you position your camera, that is, you orient your camera, you turn it, you bend, you rotate it, you orient it. So, to have a perfect picture of the natural scenery there. So, that is where the viewing coordinates comes into picture. That means, when we have placed all the objects in the world, the next step is to imagine a viewing coordinate system, which is actually a position in space and then a reference position in reference frame. From there, you are actually capturing the world. So, that is your viewing coordinate system, and once you choose the viewing coordinate system, the next step is to convert the world coordinates to viewing coordinates, and followed by that is later convert the viewing coordinates to projection coordinates. As you can see here, it is viewing coordinates, and then later it is projection coordinates, and finally we convert them into normalized coordinates, and which are finally given to the device for display. So, these are the series of steps that take place in creating right from creating or modeling an object till it is actually shown or displayed on a display device. These many conversions take place. For each of the conversion, a lot of matrices are used for conversion from one coordinate system to the other. So, from modeling coordinates to world coordinates to viewing coordinates to projection coordinates to normalized coordinates, and finally to the device coordinates at the end that you see here. Finally, the device coordinates are assumed by the objects. So, basically when it is finally shown up on the display device, we actually see the device coordinates. So, that is where the graphics pipeline goes. That is how the graphics pipeline goes. We call this pipeline because so many series of operations take place right from modeling till it is displayed on the final device. So, with this we come to the summary of this what we have learned. Let us take a recap of what we have learned today in this session. So, we have talked about some of the basic terminology, very important as part of as far as graphics is concerned. So, we have learnt about definitions like pixel resolution, pixel dimensions, resolution. We have learnt about say coordinate systems. We have learnt about the graphics types and raster and vector graphic types, the coordinate systems at the end. So, this understanding of these definitions is very important. I want you to actually have a relook into all these definitions, because we require this as the background for the next discussions, for our further discussions in this course. Thank you.